Laser beam machining. It is a non-traditional machining process. Laser stands for light amplification by stimulated emission of radiation. It can be used to cut, drill, weld, and mark with high accuracy. Components of laser beam machining. In components, it contains a power source, flashlights, glazing medium, and lens. How is laser produced? Atoms contain electrons in each cell. According to Einstein's theory, if external energy is supplied to electrons, it jumps to higher energy state. It is called absorption. However, this high energy state is not natural and it is unstable. So the electron moves back to its original state by emitting energy, which is called as photons. According to Einstein's second theory, if any photon bombards the electron at its excited state, it emits two photons to come back to the ground state of same wavelength. This is called stimulated emission. To produce an active laser, more electrons need to be in excited state or at higher energy level. This is called population inversion. Working of LBM. Consider a ruby rod which is alumina doped with 0.05% of chromium used for laser production. When power is on, photons emitted from flashlight continuously bombard the chromium atom of ruby rod. When chromium atoms are bombarded, it jumps to higher energy level, which is a non-stable state. Thus, it immediately jumps to an intermediate metastable phase. At this state, if it is bombarded by a photon, it emits two photons. This is called stimulated radiation. One end of ruby rod has fully reflected mirror, which will reflect the emitted photons back to the crystal for more emission. The other end of crystal has partially reflected mirror, which allows some photons to pass through it, which is concentrated through a simple lens to one point. Hence, the thermal energy of laser beam is converted to heat energy, which melts and vaporizes the workpiece. Advantages of laser beam machining. Both conductive and non-conductive material can be cut. It gives high accuracy, almost no tool wear. It has narrow heat affected zone. Microholes can be produced. Hard and abrasive material can be cut. Limitations of laser beam machining. Large power consumption, high initial cost, short flash lamp life, low material removal rate, high maintenance cost. Application of laser beam machining. It is used to drill, cut metallic and non-metallic materials. It gives very accuracy micro holes. It is used in electronic and automotive industry.